my talk. This is the first ever talk that I'm giving in any of the CNCF events in general. Screen is not shared. Hold on. Is the Google Meet fine? Yeah. Cool. Yeah, so I was saying this is the first ever talk that I'm giving in any of the CNCF events. Before this, I was majorly contributing to the front end community, and now I'm into CNCF, Kubernetes, and now Chaos. So yeah, uh, a bit about me. My name is Pritesh, and I work at Harness as a community manager. I take care of the LitmusChaos community, which is a CNCF incubated project. I am into communities and building communities since last 2.5 years now. Uh, I lead this React Play community, which is an open source React project. We also do meetups. I've done like 19 to 20 meetups till now as an organizer in Bangalore. I lead the Bangalore chapter. And yeah, I like creating content. I have a lot of content out there, written content probably, on my socials, Twitter, LinkedIn. And now I've started creating videos also. I'll show you the videos that I've created for LitmusChaos as well. Yeah, and I like exploring and building tools as well. Cool. Talking about today's talk, this is not just a talk that I'm here to give you. I just want all of you to feel the emotion behind why do we do it, what do we do it, and how do we do it. And I'll need your attention and your help for me to do this for this talk. Okay. Cool. I have a clicker still. I'm doing with my hand. I don't know why. Okay. Cool. Let's start with the most popular concept of outages, right? So before I built this slide, I didn't have the latest news with me, which was the recent outage that happened with AWS, right? All of Yeah, I was about to talk about. So Azure felt left out that why I'm not in the race, right? So they also had an outage recently. So outages happens now and then, and it will keep on happening. It's not something that we can have in control. But since we are talking about outages, these are some of the previous outages that have happened. Some in Salesforce, Atlassian, Microsoft, GitHub also. We have seen Instagram going down a lot of time, WhatsApp going down, and the first thing that we do is go on Twitter and tweet about it, say that this is down, that is down, and it keeps on coming, right? Cool. But what is the impact? We have seen outages, the people who are using it. So we as an outsider user, some of us might not have seen the impact because we are just someone who are not part of this process, but some of us who have been impacted, there has been different sort of impacts that happens when an outage happens, right? So I'll be talking about three type of personas who usually get impacted. First is the business, who is getting impacted because of the outage, because it's their outage, of course. Second is the users, the end users, and third is the engineering team. What do they go through at the end, right? First thing, I'm doing so wrong. Okay, fine. First is the revenue loss. So this is a very old article. It's like from 2013 or something, but it states that just because of 1 minute of downtime in Amazon, it costed them $66K. It's not a big amount for them, but the point that I'm trying to make here is there's a huge revenue loss, and that's the primary thing that is getting impacted whenever any outage happens in any company. Second is, of course, the reputation damage. The end users, the end customer that you have for your product, they are not able to use the tool or the service that you're providing at that point of time. And if it happens very frequently, they'll of course think of changing it and going to your competitors instead of you, because of the outages scenario. since you're talking about end users, there is a constant frustration and churn that happens in users' mind whenever an outage happens. That okay, it's not working for 1 hour, and I wanted to use in that 1 hour, right? There's a loss of confidence that happens from the user's perception that hey, I want to use this, but it's not working. I want to use it, and this becomes more critical when it comes to the critical industries where time is very critical in nature, like healthcare, trading. Trading in 1 second can do anything, so we cannot afford those kind of outages in these critical industries. So that's where that's what the impact an outage can make. Last is our engineering team. So even if it is a startup, if it is a big MNC, anything breaks on production, everyone from an intern to a CTO level comes on a call. Everyone is on call, and based on the how critical the bug or whatever they are trying to fix on production is, they keep on working on that just to fix that particular stuff, because they are serving the end customers, and end customers are important to them, right? Then there is once the bug is fixed, then we have this retrospection call. If you might have seen what went wrong, why did it happen, and everything, and it goes on for 1 week, 2 week, or 3 weeks or something, right? And the major issue with the engineering team when it comes to outages, the time, right? They have planned their sprint for doing something. They could have invested that time in building or making some innovation or doing something productive which might have led them different from their competitors if they built that particular feature. But it didn't happen because of the failures that they are having in production. Right. So this is the impact from engineering point of view, because they'll keep on, all the workforce will be there to fix those things instead of building new stuff. So what do we want? So what is the point that I'm trying to make here? So we want to build systems which users should be able to use, not only when everything is working fine, but also when there is some outage there. So when I say some outage there, the system should be resilient enough, the system should be able to recover whenever something goes wrong, and that's what we call a resilient system. But standing here and saying that we want to build a resilient system is not that straightforward. In today's world, we are having complex architectures. We have hundred of services running. There are microservices, cloud native tools, global traffic coming from all over the globe, right? We have hosted server in different regions. Anything can happen anytime. A small network glitch, latency issues, pod crash, misconfiguration or deployment, anything can go wrong and eventually may lead to an outage, right? So this is a high level diagram of how an infrastructure might look like. On top we have our application, then we have dependencies, databases, cloud native services, Kubernetes services, platform services, and whatnot. So more than 90% of our infrastructure consists of the elements apart from the main application which is serving the user, right? And in this case, it's hard to even analyze that, okay, what might have gone wrong, and that's why it takes a lot of time for them to decide and fix things in production. And the reason is we test code, we do unit tests, and we do all sort of testing in code. We also do performance tests so that we can serve our customers faster. But the thing where we might lack is testing the real life scenarios, right? What if what is this my system able to recover if I crash a random pod, if which is dependent on some other service, right? So we have dependencies all across different services that we are running, but we might not have tested them properly that on the real life scenarios which might have happened, And that's where chaos engineering comes into the picture. What is chaos engineering? A general Wikipedia definition is inject controlled failures to build confidence in resilience. When I read this sentence for the first time, even I didn't understood what it meant. But just to give you a layman's explanation, we inject failures in production intentionally, but in a controlled way, so that we can understand that how our system behaves when something like this will happen in near future. So we try to break the production, as Atul said in the starting of the meetup, just to understand the behavior of our system. Okay, once we do that, we'll understand, okay, if it is resilient enough, is it able to recover or not, and we will find the weaknesses and fix them before our customers find and complain about them, right? Yeah, so what happens when we do this? So we practice this chaos testing in production, because that's where we are serving the customers. But we identify the blind spots. We do the recovery strategies, and we also validate them if whatever we have strategized, if it is relevant or not. And last is gain confidence, which is most important thing. Every engineering team will get a good amount of confidence once they pass all the hypotheses or scenarios that they have built for that chaos scenarios that they have for the production system of their organization. So they will get confidence that they can handle all the real life scenarios that might impact them. So yeah, Netflix started this chaos engineering practice long back in 2010, if I'm not wrong. They built this chaos monkey tool, which helps them to do chaos engineering and validate their recovery strategies and measure the resiliency of the systems. But again, we discussed about why do we do it, because outages are something which we cannot afford. Now let's discuss about how do we do it. There are multiple different platforms which helps you to perform the chaos engineering. And today I'll be talking about LitmusChaos. Litmus is an CNCF incubated project, which is an open source tool, of course, and it helps you do chaos engineering in very controlled and safe way. I'll be giving you a short demo of Litmus so that I can give you a little overview of how things happen in practical. Yeah, we more than 250 plus companies are using and performing chaos testing and do perform chaos engineering, starting from Intuit, Flipkart, Adidas, all the names I've already mentioned. And we also have contributors from some of these companies at least. Since we are a CNCF project, as Atul mentioned, we are a vendor neutral organization. So anyone can even be a maintainer or contributor to Litmus. In recent Hacktoberfest that we were part of, we got almost 60 PRs ranging from contribution in Litmus documentation to the main core repo and also the different architecture part of Litmus. I'll be releasing a community release for whatever happened in October. If you're not part of Litmus community, if you're already part, okay, chaos testing. Thanks. So this can happen in your production as well if you do it, but I believe you build a resilient system. It's fine. Cool. All right. So yeah, this is the dashboard that I'm gonna show you anyways. We also have Chaos Hub, which is a template of 50 plus chaos experiments pre-built. So you can directly choose any of them. We have starting from board crash, container crash, and all different cloud are also there. So we have experiments for different selected cloud services as well. So you can go ahead and check hub.chaoshub.in. Cool. So this was the demo which was not working, Atul mentioned, but I don't know. He has some energy. He came there and it started working. All right. So this is the dashboard, which we call Chaos Center. Here we see all the experiments. I think Atul was right. It works there only. But okay, it came. Yeah. I think I'll zoom in a bit. Okay, I'm searching. Yeah. So this is the, how we perform experiments. Every experiment that we create, it shows up like this. Then we do multiple iterations after fixing it, again testing, fixing it, again testing, to test that if it has been fixed or not. This is the iterations column where we see all the iterations. If you go into any experiment, there's a CPU hawk experiment that has been performed, and you just drag and drop and create. You can either create your own experiment YAML and insert it here. If you go to YAML, you'll see the YAML anyways here. If you want a custom experiment, or you can go with the pre-templated experiments as well. All right. So what you do is, first of all, you create an environment, and then in the environment you create a chaos infrastructure which will help chaos center to connect with your infrastructure, and then it will be able to communicate with it back and forth, to perform and inject the faults inside of your system. And then we have probes. So when you enter a fault in your system, we need someone to measure the impact as well, right? And that's what probes do. So you configure probes to measure the impact that your fault has made to your system. And then we have chaos hub as well. You can also create your own chaos hub. You can fork this repository, and you can create your list of experiments in your own way, and you can put it here so that it will show here. Then there are other features like you can invite teams, and then you can also run on GitOps. Once you explore more, you will understand. We also have APIs in case if you want to directly make it run from somewhere else, some webhook, you can do that as well. Cool. Yeah, this was the high level overview. Here you can see the connected infrastructures, experiments performed, and everything. And I have also released a video series on getting started with LitmusChaos. This is the 10 videos playlist on Litmus YouTube channel. In case if you are new to it and if you want to explore how to perform it, go ahead and check it out. It took me 1 month to create this entire series, but it's worth. I've seen good response out of it. Yeah, cool. This is nice. This is what chaos engineering is, but I am here to announce something special. We are in the age of AI, and we have already seen a lot of AI stuff in past 2 talks. We have seen Elastic MCP, and this is time for Litmus to release an MCP as well. So I'll start with the question and a use case, and that is, imagine you telling your system that, hey, simulate this particular experiment on this service. Or you can just, if you want to understand more about your own system, you can ask that, hey, this is my infrastructure, because since MCP server will be connected with your chaos center, and your chaos center is already connected with your infra, it knows everything, and you can ask your Litmus MCP itself that, hey, this is according to what my infrastructure is, suggest me top 3 experiments that I can perform to measure the resiliency of my infrastructure, right? So yeah, this is what an MCP server will do. But how does it help, and why do we have MCP server at the first place? Because we want to make chaos engineering accessible. So starting from the start of my talk till now, you might have understood that Doing chaos is not that straightforward. You need to understand your infrastructure, you need to understand how to perform chaos engineering, you need to also think of all the different hypotheses according to your use case, and then you have to learn the tool as well, and then you have to perform it. With MCP, everything becomes easy. Even me being a developer, I can ask that, hey, what does this experiment would do, or what does this probe will do, right? You can just literally chat with your MCP to understand your infrastructure, to understand the tool itself. Now you don't have to go to GPT, which will give you again a generalized idea of everything. If you use MCP, you are closely connected with the tool and your infra, which and you can ask questions. And majorly, since I am also new to Litmus and chaos engineering, I also use it to understand and learn Litmus itself. So that can be the primary use case. But as you grow and adopt chaos engineering, because this is something which will break your production. So of course, if you are not familiar with this, or uh, one day to get started, you'll do it in your UAT or staging instance, and then gradually with a small blast radius, and gradually you'll adopt, and gradually you'll learn, and then you'll do it on production, and then you'll measure the resiliency, fix the weaknesses of your system, and then your system will become more resilient. So this is the process. It takes a lot of time and effort to do chaos, but with MCP, anyone can do it. Anyone can learn it, and learning is more important while performing chaos. I'll show you a quick demo about this as well. I hope this works. So my MCP is connected with this um, chaos center instance that I have. Let's see what does it do. So before I write something, I want to show that it is already connected with Litmus, and we have all these tools which are there, right? You can use this on any MCP host like Claude or Windsurf, Cursor, or anything that you have that you want to connect with. Now it will call the relevant MCP tool, and then hopefully it should give some answer. Yeah. So these were the tools that, these were the experiments that I had. Now, let's say you want to understand more about this or the result it gave, you can just select this and just write describe this experiment, and it will describe it. You can also ask things like what are all the faults available natively in chaos, Litmus chaos, and then once you get the answer, just ask them to detail out few of them, right? You can just chat and learn and then perform. You can directly perform from here as well. As I mentioned, you can directly, I can just ask, can you suggest me some okay. So the application that I've connected is the banking, the sample banking application, which is a typical GCP demo application. If you might have seen, I forgot the name of the tool. Yeah, Anthos. Yeah, that is connected, and oh, sorry, I thought I've done this before. Okay. Yeah. Okay, I understand this. At the end of the day, this is again an AI suggesting you to do something. There we always need a human in loop, but it makes our life easier, right? For us to do everything from scratch, for us to learn everything from scratch. This is the place where things get easier, and then you adopt it, and then you do it. Yeah. So you can do pretty much everything like this with Litmus MCP. If you want to use it, you can go to Litmus. Okay. Litmus CP server. Yeah. Yeah, you can follow this guide. I think we also have a documentation now. I think here should be much. You can go it from here also, or if you go to docs, not, I think it is merged. Yeah, you can get the guide here as well. Everything you need to know to get started with Litmus MCP server. Yeah. Cool. So this was it. I hope I was able to deliver the idea of what chaos engineering is and how do we do it, why do we do it. And I hope you enjoyed the talk. And yep, thank you so much for listening to me.